This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Okay, hello Bob.
Hello.
Hi. So today I'm talking to Bob Martin, also known as Uncle Bob. We're going to talk about all kinds of things of Agile, software craftsmanship and things like that. But before we get started, Bob, why don't you introduce yourself to our listeners?
Well, I'm Bob Martin, founder of Object Mentor. Been a software developer for many decades now. I think 4 decades. And my motto at this point is, I want them to find me with my nose between the keys. I'm perfectly happy as a software developer. It's what I want to be.
So you didn't become an architect or a business analyst or a designer?
I've done all of that.
Okay.
When you're young and you think, "Ooh, I need to grow in the enterprise or in the company," and I went down the management track for a while, and I became an architect for a while, and I did all of that stuff. And what I really found that I wanted to do is write a lot of code, and that's what I do. I write as much code as I possibly can. I teach people how to do it. I consult with people about how to do it, how to run their teams, and how to run their software groups. But mostly, I want my fingers on the keyboard.
So that means that if you say you write code and you consult about writing code, it also includes the process of writing code, i.e. Agile, soft skills, team issues. Absolutely.
It's the whole enchilada. Object Mentor is a company that helps software teams, adopt and adapt Agile processes and just in general good craftsman principles.
And we'll talk about the craftsman aspect in a minute. But if you say you did architect and analysis and design and stuff, what is it that you don't appreciate about these things? I mean, obviously, sometimes these people don't actually write code, but do you think things like architecture, assuming you can define it, is worthwhile? Or do you basically say that, basically all that matters is code and you refactor and things like that?
No, I think architecture and design are extremely worthwhile. What I don't appreciate, and that's a very good use of the words, what I don't appreciate is the separation.
Right.
I don't think architects should be non-coders. An architect, the best kind of architect, is an architect who codes for a living and lives in the architecture world that he makes for everyone else. One of the problems we have in this industry is that we separate the leaders from the code. And these leaders, the architects, go off to make decisions that are critical decisions, and yet they become unconnected to those decisions because they don't have to write code that reacts from those decisions. They don't get to live in the bed that they make for everybody else.
Yeah,
so the important thing about architecture and architects is that they keep their fingers on the keyboard. And the same is true of team leads and first-line managers. It is way too simple to forget about the code and think, well, that just belongs to somebody else, and I need to deal with the management. And the reality is that you can't manage a team, you can't lead a team, you can't provide architecture for a team unless your fingers are on the keyboard and you're seeing what that team and experiencing what that team is doing.
Yeah. And, okay. So to me, looking at what you say from 10,000 feet, that basically sounds like what, Agile. Okay. So XP, Agile, the idea that the architecture is something that lives in the system and not in PowerPoint, and the team owns all the artifacts. Architecture is something that evolves as the team decides what they want to code and how they code it. So is it that are you basically saying the Agile way is the right way?
Well, I don't like to circle any method and say this method is pure truth. Agile is not Schindler's List. the Agile mechanism, or the way we do Agile, is that, yes, the team produces the artifact. But there's no reason that an Agile team could not produce a design document. There's no reason that an Agile team could not produce an architecture document. The architects within that team, although they write code, will probably also create architecture documents in UML or something like that in order to communicate with other teams or with other groups. There's nothing wrong with that, and I don't want to give people the idea that Agile is a non-document driven approach. Sure. In fact, it's very heavily document driven. Yeah. But the team decides on the artifacts that are necessary. The team with the architects and the team leads in place decide which documents ought to be promoted outside, so they're talking to other teams. And the ultimate document, the document that is the most important, code itself. All the other documents are reflections of what's in the code. This is as opposed to with the waterfall or other kind of plan-driven approaches where the code is the result and not the driving document. In our case, what we like to think is that the code is the driving document, right, and all other documents reflect what's in it.
Yeah, they kind of explain certain aspects from the code that are not easily obvious when looking at it, yes, easily. Yeah.
Yes.
So you're quite well known for many things, but one thing in particular, and I think that's software craftsmanship. Although I think you were not the person who initially created the notion, but you're today quite involved in this stuff. So do you want to introduce us to the idea?
Well, so it was Pete McBreen who originally wrote the book entitled Software Craftsmanship, right, and it was a wonderful book. He talked about the parallels of the software industry with mid-age guilds of craftsmen, and he talked about the notion of apprentices who would hook themselves up to a master and learn the tricks from the master, and then they would go on a journey to other places, becoming journeymen, and eventually they would become masters as they did their masterpieces and become well known for what they had done. When I read that book, I thought, well, that's a very interesting concept, and it's close to the way software is really learned.
Yes.
Our civilization has put almost everything into this box of you learn things at college and then you do things on the job.
Yep.
And that's just not the way it works in software particularly well. When software developers come out of college, they know very little about what is going to have to be done on the job. And they learn most of what they need to know on the job. For a lot of software developers, it's quite a culture shock to come out of school and suddenly realize that, oh my gosh, this is a very different job than I thought it was going to be. And unfortunately, many of them are at sea. There's no mentor they can hook to. They've got to learn it all by trial and error and by making mistakes. And what we need is a system whereby young software developers, whether they go to college or not, hook themselves up to a master. Learn from the master. Learn from a set of mentors. Journey from place to place, either different departments within a company or different companies, learning to become journeymen, learning the skills and the ways to make decisions until they can settle down and really understand their craft and perhaps become a master. So the whole notion of craftsmanship, the whole flow of craftsmanship is this idea that you learn from other people by helping them do, not by listening to lectures and studying books.
Yeah. So is software craftsmanship something that has an educational focus or about training developers, or is it more like a way we develop software? I understood the educational part. So where does the second part, the doing things in a certain way, come in?
This is an issue of pride of workmanship. And again, this is something that that in our civilization we are somehow lacking, especially in the software world. One of the things about being a craftsman is that you learn how to work, and you develop a certain amount of pride, in fact, a good deal of pride, in the way you work. Now, you're also proud of what you produce. Mm-hmm. And most software developers have that feeling. Oh, I produced a wonderful system, or I wrote a great module, and I'm very proud of the module I wrote. But the craftsman view is that not only are you proud of the modules and the systems you wrote, you're proud of the way you wrote them. Mm-hmm. And even if a particular module or a particular system does not succeed in a commercial sense, you can still be proud of the way you produced it. There's a set of disciplines and a set of skills and a set of rules that a craftsman will follow that are difficult to follow. And, they're hard disciplines to work into your psyche and into your way of thinking. And once you've adopted them and you follow them well, you can be proud of the way you work.
So if you say the way you work, well, maybe you've just answered it. Is it about the process of how you do something, or is it about the intrinsic structure and values and qualities of the thing you built?
Both. There's an aspect of the process involved. So I am proud when I can follow one of my disciplines, test-driven development, for example.
Right.
I am proud of the fact that I can follow that discipline and follow it very closely and create systems that have high degrees of test coverage and have been assembled through the process of writing one test case at a time. I am proud of the fact that I have learned that discipline and internalized it and I can apply it. But I am also proud of the structure of the code, the structure of the design. I can look at the code and know that I haven't left any messes behind. I can massage the code until I think it is appropriate for the business purpose that it's set for. So there's several levels of pride here. Pride in workmanship, in the process, in the final product, in the success of the product when you're done.
Mm-hmm. So you mentioned test-driven development as one of the disciplines of the software craftsman. Do you care to mention two or three more so we can get a feeling of what you think what you mean when you talk about disciplines?
So there's several practices that we can talk about. One of them is test-driven development, of course, and I could spend an awful long time talking about that one. Another one is continuous integration or continuous build. The idea that as a team of developers, we will check in our code very frequently, automatically kick off builds, automatically run the entire test suite, and keep that test suite passing at all expenses. Right? No matter what, we will keep that test suite passing. When the test suite breaks from an automatic build, it is a stop the presses event. Everybody on the team stops what they're doing and figures out why the test suite broke. They get it working again, and then they continue to make progress on their tasks. Again, this is a discipline, and it's one of those disciplines that's easy to drop. A team under schedule pressure might look at a failing build and go, oh, well, we'll deal with that later. One says, no, stop. No matter what the schedule says, you stop, you get it working again, and then you can make progress. So continuous integration is another one of those disciplines. Pair programming is a discipline. And it's one of those disciplines that is extraordinarily helpful, but it can be overdone. There's a religious aspect to it that I don't appreciate too much. So usually I suggest people pair on the order of 50, 60, 70% of the time, but certainly not on everything.
Right.
On the other hand, there's a discipline involved with this. It's easy to say, well, I just don't have time to pair. I just don't have time to do this. There's just too much schedule pressure, and that's very detrimental to a team. Teams, good craftsman teams, should be pairing a fair bit of the time.
So, but these disciplines are basically the usual suspects from the Agile crowd.
And in fact, they're the usual suspects from the extreme programming crowd.
Okay, yeah.
Pretty well focused towards extreme programming because of all of the Agile processes. Extreme programming was really the only one that named any discipline.
That's true, yeah. But they have been kind of generalized. Most of the people who call themselves Agile developers, even if they don't do XP, would agree to those disciplines and practices. Now.
Yes, I think that's ironic because when you assemble them all, you're actually doing XP. we don't like the X and the P. So
No. I mean, they don't. No, the point is they probably don't do all of them. I mean, I know several teams who do continuous integration and test-driven, but they don't do a lot of pairing, for example.
Yes, and we could call those teams Agile. That's fine.
Right.
The whole point of Agile was to broaden the population of people doing these processes.
Yeah. So there is a manifesto for software craftsmanship.
There is, yes.
And what does it say? I guess most people know what the Agile Manifesto says. So I guess you can relate it maybe to what that says.
Oh, goodness. I think I have to pull that up on my screen.
I did that already. So I'll read you the 4 things one by one, and you can comment on them, right? So not only working, so there is this, as aspiring software craftsmen, we are raising the bar of professional software development by practicing it and helping others learn the craft. Through this work, we have to come to value not only working software, but also well-crafted software.
Yeah, now this is a bit of cleverness by the authors here. They took the 4 statements on the Manifesto of Agile Software Development. And then they essentially moved to the left and added another column.
Yeah.
So the Agile Manifesto says we value working software as opposed to something I can't remember.
Yeah, probably.
And now this says, okay, well we do value working software, but it also has to be well crafted.
Yeah, it's actually
and the notion of being well crafted is that it more than works, and it's software that works is fine, but software that works and can't be maintained or can't be understood is a frightening thing to have in the system. And unfortunately, most of the systems out there are in a state of rather serious disrepair.
Yeah.
And this disrepair is hidden from the users. What the symptom is that managers will ask for new features or bug repairs, and the estimates for those new features and bug repairs begin to stretch. They get longer and longer as time goes on. The software developers feel so unsure in their code base that they start stretching the estimates. I have worked on systems where estimates started at something reasonable like a week, but 2 years later there was no estimate shorter than 3 months.
Yeah.
And that is a common symptom in software industries today. Then the reason it happens is that the code base falls into such horrible disrepair that the software developers themselves don't trust any of their actions within it.
Yeah.
So they have to be incredibly careful and pad all of their estimates because they simply don't know what's going to happen when they change a line of code.
Yeah.
The notion of being well-crafted is that we know what's going to happen when we change a line of code. We understand what the repercussions of every change is. We can look at a module and understand what it does and understand what the couplings are. We have the tests around it so that we know at a push of a button that any change we make hasn't broken anything else. And the software is, in general, good. And that's, for some reason, that idea is foreign to most of the software industry out there. The focus has been so much on schedule that the software development community has all but abandoned structure. And this is ironic because when you abandon structure, your schedules go out almost infinitely.
Yeah.
The only way to keep your schedules under control is to keep your quality very high.
Yeah.
So the first line of that manifesto has a tremendous amount of implication.
Yeah. Okay, let's look at the second one. The second one is not only responding to change, but also steadily adding value.
Okay. So the Agile Manifesto says, we need to not only have contracts and interactions or something, but we also want to be able to respond to change. The Software Craftsmanship Manifesto says, yes, but we're not just going to respond to change. Every time we make a change, we're going to be adding value. And that value might be added in terms of new features, it might be added in terms of defect repair, or it might be added in terms of improved structure or improved cleanliness within the code. There's another way of saying this. I wrote a book not too long ago called Clean Code, and in that book, I described something called the Boy Scout rule, or the Boy Scout principle. Boy Scouts have this rule that says, when you leave a campground, you always leave that campground cleaner than when you entered it. If we did that in our code, if we checked in our modules cleaner than when we checked them out, if every time we touched the code we left it better than when we started, our code bases would improve and improve and improve. So this notion of steadily adding value every time we touch the system is one of both in what the system does and in how it is structured. We never, ever let it go.
I was about to ask, it's not just adding business value, it's also about adding intrinsic value, making it more well-crafted in some sense.
And this is important. There is, business value is critically important, and it's tempting for the outside world to say, oh, this software craftsman community, all they care about is the cleanliness of the code. They've given up on business value, and of course, nothing could be farther from the truth. We are strongly focused on business value, but we also understand that the way to keep business value high is to keep the internal cleanliness of what we're producing high.
Yeah.
You can't decouple the two.
Right.
And that's the big mistake that the industry has made. They have decoupled the business value from the internal structure of the system.
Yeah. Next one is not only individuals and interactions, but also a community of professionals.
Yes, again, that's the echo from the Agile Manifesto, which then goes on to say we certainly want to have interactions with individuals and so forth, but we also want to create a community of professionals. And this goes back to the whole idea of masters and apprentices, journeymen, the idea that we will grow within our community the next generation of masters, the next generation of journeymen. That it is the responsible of the software community itself to train the new professionals coming in. That we don't become islands unto ourselves, that we share our ideas with each other and become a community of profession.
Mm-hmm.
And it's hard to make parallels. We could talk about lawyers and how they have the bar association. We could talk about doctors and how they have their various medical associations.
Yeah.
I don't know that the software community wants to go in that direction, but some kind of community where we share professional values, we share disciplines, we have ideas that we freely exchange.
Right. Mm-hmm. Okay, and the last one is not only customer collaboration, but also productive partnerships.
The idea here is again pretty simple. We are not just the employees of the customer, or we are not just supplying systems for the customer. There's a partnership involved. Mm-hmm. We identify with the customer's needs. We are bound by the customer's needs. So we need to focus on what our business customers actually need and help them make their systems appropriately. Maybe the way to explain this is to describe what it would be like if we didn't do this. Sometimes you will see teams that will take requirements documents from their customers. They read the requirements documents. They realize the requirements documents are flawed, but they go ahead and implement them anyway because that's their job.
Yeah.
That's not a partnership. A partnership is when you look at the requirements document or you look at anything the customer says and you get involved with it and try and make the customer's needs your needs as well. You are involved with the decisions and you are productively partnering with them.
Of course, the customer also needs to be willing to partner. That's not always the case.
Yeah, yeah, that's true. But a craftsman in this world of this manifesto, a craftsman would probably not work for a customer that was unwilling to partner with.
That's a very good point. Yeah.
Yeah.
So I think the idea of, as you said, moving the Agile stuff one column to the left and adding stuff is really a good trick, because it shows that it builds on top of the Agile stuff, right? It's kind of an extension of what the Agile Manifesto and the Agile community already has.
Yes. Yeah, and that was the idea. It was a brilliant idea by, I think it was Doug Bradbury who had that idea when the manifesto was in the throes of being authored.
Yeah. So most of these, let's call it a movement, right? Most of these initiatives, movement, are a reaction to trends in a community or in an environment. And as we already kind of discovered, there was already the Agile stuff, the Agile community, the Agile Manifesto, and still there was something that prompted the originators of the craftsmanship movement to do something in addition to that. Can you talk a little bit about the history, why this craftsmanship thing came around? Why isn't Agile enough? I mean, we saw the manifesto, but what prompted it?
So we need to go back in time,
yes,
maybe 15 years, to begin this story. And at that time, the waterfall model was the king. And everyone believed that what we really needed to do was define our requirements so well, and then go through and define our designs so well that we might even be able to generate all the code from the designs. And you'll remember there were even ideas about case tools that software developers would do their designs and then generate the code. This was an extremely popular idea. It was almost the grand hope of the mid-'90s. And while that was going on, there was this subculture that was fermenting. The papers about Scrum were published in '95 by Ken Schwaber and Jeff Sutherland and Martine DeVoe. And that had an interesting effect on a small part of the community. People started realizing, wait a minute, this whole idea of waterfall just doesn't work so well. Jim Copleen published a wonderful paper about business, or software process patterns, and there were a number of interesting aspects of that. For example, architects also code, one of his patterns, and if you looked at that carefully, you could begin to smell the beginnings of the Agile movement beginning. The late '90s is when Kent Beck started really writing about the ideas of extreme programming. I don't even think he called them extreme programming until '98 or '99. Yeah. And that created a revolution. There were a whole bunch of people who looked at those principles and suddenly realized, we've been focusing wrong. This whole time we've been focusing wrong on the grand waterfall scheme. And what we really need to do is work in really short cycles and get our systems so that we can ship them once every couple of weeks and write lots of tests and pair program and all of this stuff. And it created this group of people who decided that they were going to look at the industry completely differently. Mm-hmm. Now, some of the disciplines involved there were extremely code-centric. Test-driven development, for example, pair programming, for example. We had virtually abandoned the notion of code-centric disciplines in the early 90s. Just the whole idea, forget it. That's not where the solution was. The solution was off in the design space somewhere. And we were focusing on UML and meta-models and meta-meta-models and so on. And along come these disciplines that are code-focused. And as we began to apply them, something happened inside of me, certainly, and I think inside of many other people. And this gets back to something we talked about before, we started to feel proud. Proud of the way we were working, proud of the code we were producing and the way we were producing that code. And I believe it is in that pride of workmanship that the notion of craftsmanship started to ferment, that people started thinking, wait a minute. This is the medium we work in. It's code. We produce code. That code serves our clients, but we need to be good at writing that code. We need to be proud of the way we produce it. And so that started this fermenting maelstrom of ideas, out of which sprang the notion of craftsmanship.
Yeah.
So it's interesting to look at when Pete McBreen's book came out, which I think was 2003-ish, 2004-ish, if I remember correctly.
Yeah.
And the ideas of craftsmanship that began to spring out after that. There were a number of abortive attempts to talk about apprenticeship and mastership, a few meetings that were gathered together but never came to anything. And now finally in 2008, 2009, we see the momentum has finally built to the point where there are whole conferences dedicated to the notion of software craftsmanship.
Mm-hmm. One thing that comes to mind, if I hear craftsman or craft in general, is industry. So the kind of opposite of craft-based doing something is industrial something. And so you already also mentioned case tools and some of that stuff. So where do you think, or is there something like industrial software development? Does this term even make sense? And if so, does it exist? And is it something we wanted to have? Or could that be an evolution of craftsman-based work? Or any thoughts on that?
Yeah, plenty of thoughts on that. First of all, we have to be careful about the definition of the word industry. Perhaps what you're thinking of is manufacturing or factory.
Absolutely.
When we think of manufacturing or factory, then we think of rows and rows and rows of cubicles with developers who have been given tasks and they're faithfully doing those tasks, and some management is going to assemble those tasks into a working function. And certainly that's not where we want to go. The model that I have in my head is different. It is the model of doctors and lawyers. Now there is a medical industry. There is a legal industry, but we do not have cubicles and cubicles and cubicles, doctors working on one little aspect of a problem. What we have are craftspeople. Doctors are craftsmen, kind of the ultimate craftsmen. These people focus on their discipline for their entire careers. In parallel, a good surgeon is like a software developer who never goes into management, who never even thinks about it, who focuses on his ability to construct code. That's a craftsman, and I think that's the direction our industry is moving. We are going to be producing, I hope, people who are dedicated craftsmen who for the length of their careers, focus on their ability to construct working software, who do not view the coding aspect of software as just a quick step before they go into management.
Let me provoke you a little bit, okay?
Certainly.
So actually, when I said industrial, the thing I had in mind was more like the automated robotic, vehicle manufacturing plants. Okay,
yes.
That was the kind of industry. So I was thinking more in the direction of automation, mass customization, and things like that. So if I say I'm a craftsman, I like what I do, I like coding, I like producing well-crafted code, and that's what I pride myself in. How can I make myself more productive? Well, I can build a robot which does the job for me. The code that is spit out at the end, or the product, is still as good. I mean, the cars that Daimler produces today aren't any worse than those they produced 30 years ago, just because they're assembled by robots. Okay, so I could create machines with my craft. As a handiwork, I create machines which then can automate my craftsmanship. Is that something that's thinkable?
Oh, it definitely is thinkable. Not only is it thinkable, we've done it. Look at the IDEs we use today, the environments that we program in today. We're not punching cards anymore.
Mm-hmm.
We're not writing code on paper tape anymore. We have these massively flexible systems that allow us to enter our code into edit windows and then select chunks and refactor it here, or extract methods there, or promote classes here, or move members down there. We have these wildly complicated automated systems that allow us to manipulate our code in fantastic ways, and that is just improving.
Mm-hmm.
Now, let's go back to the notion of automated factories for cars. Once we have designed the car, we can then hand that design to the factory, and the cars just pop out.
Mm-hmm.
But some creative energy had to go in to designing that car, and that creative energy is all human.
Yes.
So the purpose of the factory is to take a set of decisions made by humans and then automate the result.
Right.
This is certainly what a compiler does. That's what an IDE does. It takes a set of decisions made by a human coder, and then it does everything else necessary automatically to turn that into a binary executable. So you can look at the IDEs we have as that factory, and those IDEs are wonderfully complicated and tremendously powerful.
Mm-hmm.
And the decisions being made by the humans are all human decisions that can't be made by them.
Yeah.
There is a movement out there that says, well, maybe what we could do is write models, UML models, and then have those UML models converted into code. Well, that's fine. If we want to do that, that's fine. I don't object to that at all. The issue there is that all the programmers who are now writing code will instead be drawing models.
Well,
and the decisions that they will have been making in code, they will now make in diagrams. And it is not at all clear to me that those decisions will be intrinsically different or better or at a higher level. They'll just be in rectangles and arrows instead of ifs and whiles.
Well, I mean, this is actually exactly the place I wanted you to get to, because I work quite a lot in modeling and code generation and domain-specific languages. Now, I usually don't do UML because I hate UML. And I also got to the conclusion that graphical models is usually not very useful. So I do a lot with textual languages. I build specific languages for specific projects or, domains. And so that is, in my experience, extremely productive. But of course,
it certainly is.
Of course, what you say is obviously true, is that the creative energy goes into language and generator design, and the generator, once you run it, of course, only executes kind of stupid rules, but it makes me get rid of some of the grunt work that's involved in coding against certain stupid platforms, okay?
Yeah, absolutely.
And I wanted
the whole idea of domain-specific languages is very, very powerful.
Okay, so you're not opposed to that. And when you were talking about the case, I mean, you sounded negative regarding the case tools in the 80s and 90s. And some people say that DSLs are just case redone. I don't think so, but that's why I wanted to find out about that.
No, I think the case tools of the 80s and 90s were a bad idea. They didn't pan out. There really wasn't a way to generate reasonable code from those models. And the same is true, I think, of the MDA approach that is currently out there. I just don't think that's going to go anywhere.
Yeah,
but the notion of domain-specific languages, that's an entirely different thing.
Okay, good. Yeah,
and we deal with that all over the place. Java is a domain-specific language.
Well, but it's a very big domain.
It translates a human understandable form into a machine understandable form. Now, there are better domain-specific languages if you want to, for example, create a finite state machine.
Yeah.
Right? Then there's another domain-specific language you can put on top of Java or on top of C++, or if you want to create a database schema generator.
Yeah, sure.
There are domain-specific languages for that. I love the idea of domain-specific languages. I think everybody should be thinking in those terms.
Okay. Good. Then we're very much on the same page here. Not that that's important for this interview, but it's still interesting. So, what are the tools of a craftsman? I mean, if I look at the carpenter, he's very good at using certain tools, the hammer, and I don't know, I shouldn't, use analogies that I don't know anything about. So, what are the tools that a craftsman should and has to work with?
That's a good question. And obviously the first one is the editor, or nowadays I would call it the IDE.
Yeah.
There are people who still want to work in editors, and I think that's unfortunate. Although, I don't want to say too many bad things. TextMate, for example, is a very high-end editor. Lots of people like to use it. Fine.
Yeah.
Want to. I prefer the more integrated environments like IntelliJ or Eclipse.
Yeah.
That are just immensely powerful, especially if you're using Java or one of the languages that they're tightly integrated with.
Yeah.
So the first tool is the IDE, and the trick to the IDE is to learn it inside and out. Get to the point where you don't need the mouse. Learn the hotkeys. Learn all the shortcut keys. Take a day and say, today is the day without the mouse. Unplug the mouse and do absolutely everything through the keyboard so that you learn the IDE backwards and forwards. There is no good reason for a software developer not to be extremely tightly integrated with editor, IDE. Another really important tool is source code control. And honestly, there are still teams out there that don't have it. That are, storing flat files in directories and editing them without any kind of source code control. This is just sheer insanity for anybody to be doing that in this day and age. Good source code control tools out there. There are plenty of them. For some reason, the free ones are better than the ones you pay for. Why?
Yes.
Seems to be the case. CVS is okay. Subversion is better than CVS, and my favorite right now is Git. So, good source code control system is also important. A bug tracking system is important with certain caveats. I do not want a bug tracking system that holds thousands and thousands of bugs. It seems to me that if you have even a very large system with thousands of bugs, you've done something wrong.
Yeah.
So I want my bug tracking systems to be very lightweight, very simple to use, probably web-based, and I don't want to find thousands of bugs in them.
Yeah.
A good unit testing tool, JUnit, or the whole XUnit suite is a good example. Or if you're in a language like Ruby, RSpec and Cucumber, excellent. A good acceptance testing tool, Fitness, for example, or Green Pepper, or JBehave, or again, Cucumber. Good, excellent tools for doing acceptance tests. And the list could go on. Notice that I haven't mentioned a debugger.
Okay.
Although the IDEs do have debuggers, it seems to me that the notion of a debugger has become less and less important with the advent of test-driven development.
Yeah.
I still use the debugger, but it is nowhere near as important as it used to be. You have to have one, but don't use it too much.
Yeah. I was actually very surprised that you didn't mention the programming language as the first tool.
Oh, that's interesting. And there are like a zillion programming languages out there all of a sudden.
Yeah. Why do you think this happens?
I think that's very interesting. We went through a period where in the late 70s, early 80s, where the issue of language was pretty well restricted to C and Pascal. And there was this war between those two languages. And the C language won it pretty well, pretty handily. Probably because it was so close to assembly language that most of the guys who were doing assembly language just kind of shifted over naturally. Then C++ came along, and so did Objective-C. Those two came along right around 86-ish, 85-ish, something like that, and continued to gain popularity, although C++ obviously went way ahead of Objective-C. And Objective-C virtually died and was only resuscitated by Steve Jobs later on. C++ became the object-oriented language. That was, oh my goodness, we're doing object-oriented now, and C++ was the language for that. And everybody else who was doing OO was doing it in some fringy little language that didn't matter so much. And then Java came along. This is like 95. And the whole idea of the virtual machine. Now, something funny happened right around then. None of these languages that we were dealing with, C, C++, Pascal, none of them had any kind of corporate backing. Even C++, which kind of had an AT&T smell to it, really was not a corporately backed language. But companies like Sun looked at the way that programmers dealt with their languages, and they thought maybe we could capture the hearts and minds of the programmer if we sponsored a language. So the era of corporate-backed languages began. And that's where Java came from, and of course C# is really just Java with a different spelling. And those languages became the corporate-backed languages. Now, software developers are like a herd of cats. They don't like to be corporately backed. They don't like the idea that there's some bureaucracy out there that is telling them what's in their languages making decisions about, well, you shouldn't have multiple inheritance because that's evil. So there's this thing going on in programmers' minds that they're feeling constrained because there's these non-programmers with non-programmer intent designing languages for them to use. So there's a subculture that starts, and the guys are doing Python, doing Ruby, and little ideas are popping up. And this kind of quantum froth at the bottom of the language level. And a couple of those start to peak out, like Ruby, like Python. And a few people start saying, well, we ought to try this Python stuff, just see what happens. We ought to try this Ruby stuff. A company like 37 Signal says, you know what, we're going to do this whole thing in Ruby because, well, we want to. And we're not tied to any kind of corporate thing. Something else happened. And I think the two are very tightly linked. The Agile movement happened. And the Agile movement was, in some sense, a break from the corporate backing, because corporations had backed the waterfall model, and the Agile movement was kind of a revolution, saying, wait a minute, don't like this. You want to do things a different way, a way that we think is better. So the mindset is in place, this kind of revolution or resistance to the grand bureaucracy that was trying to be imposed. And one of the disciplines in Agile was test-driven development. And test-driven development had an interesting role to play in especially the adoption of Ruby and Python, because these languages were dynamically typed. Now, the war between the statically typed and the dynamically typed languages was fought in the 90s, and the dynamically typed languages lost it, particularly Smalltalk. It was just over. Right? The strong static typing of Pascal and C++ and then Java was just the way that programmers wanted. Along comes test-driven development. Test-driven development says, well, you're going to write a whole bunch of unit tests here. Absolutely every line of code is tested. And programmers look at that and they think, yeah, it works really well. I've got all these tests. It's terrific. Why do I need the compiler to check my types for me? These tests are doing that. Why do I need the compiler to constrain me? And so a group of people, I think, started playing around with dynamic languages again. And the motivation for dynamic languages is pretty clear. They are highly productive. You can get stuff done in Ruby 5 times faster than in another language. And that's something that's been measured over and over again. And the reason people didn't use Ruby is because it was dangerous. It's a dynamically typed language. But when you're doing test-driven development, the danger goes away. And so I think the combination of the revolutionary attitude from Agile and the discipline of test-driven development and these little dynamic languages popping up caused an opportunity, a window, and languages like Ruby, especially Ruby, and Python, just started to become very popular. This is something that the corporate world should note. Whenever the corporate world creates a standard, that standard will be doomed. Because there will be a group of revolutionary people who have ideas they'd never thought of before and will overturn it. And now we're seeing the same thing happening, right? We've got this wave of dynamic languages, specifically Ruby and Python, but others as well, that are becoming very popular, but you can see the wave that's coming behind it. And the wave behind it is all the functional languages. Clojure and F# and Scala and Erlang, and Haskell even has something like this, although it's down in the mud. And these languages, people are looking at those and going, this might be pretty cool, better than maybe these dynamic languages. Look, some of them are even statically typed again, except that they're so easy to use. They're stateless and blah, blah, blah. So there's this yet another wave that's coming. And again, it's not corporately backed. Well, it sort of is. The F# has a corporate back. Scala really doesn't, but, So we're going to see how this all plays out. I think it's very, very interesting.
I mean, basically you said that you implied that most of the languages that come around are dynamically typed, and in that sense, Scala is really the exception. And I think that one of the motivations for why Scala came around is just because Java didn't evolve, and because it's, especially with its generics, the way you had to use typing in Java is just a pain. And Scala, even although it's statically typed, just does a way better job there.
Yeah, well, it uses the type inference nicely. So
exactly.
You have this dynamic feel.
Yeah.
Even though it's statically typed,
exactly.
You have this dynamic feel to it.
Yeah.
And it's very interesting.
So what does that mean for the software craftsman? I mean, should he learn all of them? Should he read a book about all of them? And since at least learning all of them is impossible, which one would you recommend, or how do you decide?
Oh, no. Software craftsmen should learn as many languages as possible.
And what do you mean by learn?
Learn. Learn means be able to write code in. You might not be highly proficient.
Okay.
But you should be able to write code in these languages. And this gets to an interesting issue. When does the software developer, when does the software craftsman learn these languages? And the answer to that is not on company time. It has to be on personal time. And this is an aspect of craftsmanship that is highly important. Doctors do not work 9 to 5. Lawyers do not work 9 to 5. Craftsmen in general do not work 9 to 5. The software development job, the career of being a software craftsman, is not a 9 to 5 job. You work 9 to 5 for your customer, and then you spend an appropriate amount of time, which I think is about 20 hours a week, frankly, on improving your own skills, learning other languages, learning other techniques, honing your abilities so that you are a better and better craftsman.
So your answer is...
What languages should we learn? I think every developer ought to learn at least one dynamic language, at least one static language, at least one functional language. A logic language would be good, like Prolog. It would be great if everybody learned Forth. Boy, that'll blow your mind. There's just a whole bunch of interesting ways of thinking about programming that you can only learn by looking at a language that presents it in a way that you hadn't thought. Everybody should learn Lisp.
Okay.
Have you read the Structure and Interpretation of Computer Programs by Abelson and Sussman? Have you seen that book?
No, I haven't. I have read other Lisp books, but not that one. So
this is a fascinating book. It's Abelson and Sussman, Structure and Interpretation of Computer Programs. It was based on a course that they taught at MIT. Their lectures are actually online. You can get them for free and watch them. This book starts from the atom. It doesn't assume you know much about programming. It starts at the atom and leads you through basic computing, simple algorithms, procedural programming, object-oriented programming, and by about page 200, after they've talked about all these interesting topics, they finally introduce an assignment statement. And I remember reading through this, and the book is, you read this book at light speed. Every sentence has data in it. It's a very concentrated book. So you're flipping the pages at light speed, reading this stuff. Fascinating reading. And I remember I was reading through it. I got to page 200 and something, and they introduced an assignment statement, and it hit me like a ton of bricks. The entire book before that, there were no assignments, and they had covered virtually everything about computing. And then they introduced a fascinating book, all done in Scheme, of course, Lisp, variety of Lisp. Fascinating. Everybody should go and get that book and read it because it's unbelievable.
Do you know the book Concepts, Techniques, and Models of Computer Programming by Van Roy and Haridi?
No, haven't heard of that one.
Okay, that's kind of similar, I guess. They also introduce various, approaches to computing: functional, sequential, declarative, logical, all these things, all based on the same, let's say, language they grow. So they add, one new language feature, and that gives them data sequential programming and stuff. Very interesting. Very interesting.
Cute. The other book, the Structure and Interpretation of Computer Programs, does not add new features to the language.
Sure.
Because in Lisp, there are only 2 features in the language.
Yeah.
But they add different capabilities by using the language in interesting ways. What was the title of that book again?
Concepts, Techniques, and Models of Computer Programming. Van Roy and Haridi. So which of these languages do you think have a chance of standing the test of time, in your opinion?
Well, I think Ruby's already there.
Yeah, sure.
I think Python's already there.
Yes.
Those 2 languages are going to...
Sure, they're not new.
No. F# and F# and Scala, maybe. And the Scala language is interesting, although it's also a little bit cluttered. I think they tried to do a little too much in there. It may be that that none of the current batch of functionals will actually stand the test of time, but that some other language like them will come along and integrate the concepts just a little bit better. Could I see myself doing a whole bunch of Scala programming? Not yet. Not yet. Maybe, but not yet. Could I see myself doing a whole bunch of closure programming? No, not really. Yeah. It is Lisp after all, and there's Lisp just has lots of parentheses.
Yeah.
Could I see myself doing a whole bunch of Haskell or Erlang? Well, probably not. So, but I think the ideas are out there. So there's going to be some language that's going to do this. I just don't know what it is yet.
Yeah. I think that's really, as you say, that's the core message. It's not about learning or understanding or even using all these languages, because let's face it, most people don't have the chance to use most of these languages in their real work. But learning them to an extent where you understand the ideas and where you can use the concepts, maybe by emulating them or perhaps by building a little DSL that contains some of these things, is a very, very good idea.
Absolutely.
Okay. So that brings me to the end of what I had prepared. Do you have anything to add, any words of wisdom?
Words of wisdom. I think the most important thing for any software developer, anybody who is aspiring to be a craftsman, is the notion of continuous learning. Never ever stop learning it. And again, I'm going to play that back as through the lawyer and the doctor filter. Imagine a doctor who stopped learning in the 1950s. Would you go to him? And of course you would not. The man would not know the latest procedures, the latest drugs, the latest ideas. Why then would an employer hire a software developer that stopped learning in 1995?
Sure. Yeah.
Stopped learning the different language. The most important trait of a software developer is the ability to continuously learn at high speed. The fire hose is simply never turned off. You are always drinking from it. You always have to keep ahead. And this industry moves at such high speed that even when you're an old coot like me, you better be learning awful fast. All the time.
Okay. This is, good summary. So, I guess, thank you very much for taking your time and being on the show.
Oh, you're very welcome. I had a good time.
Okay, very good. That's good to hear. Thank you very much.
Thank you.
Bye.
Good to talk to you. Bye-bye.
Bye. Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.